Hello ladies and gentlemen, it's Mrs. LaJoy here. Today we're going to look at factoring and greatest common factor and trinomials and the difference of squares. So lots of stuff. So greatest common factor. Well, first of all, we have to talk about what factors are. Factors. So factors are numbers that go evenly into a larger number. So numbers that fit evenly into larger numbers. So for example, if we are looking for factors of 12, so we want to find which numbers go evenly into 12. So one way to do this, well, this is simple if you know your multiplication tables. But I'm going to show you a way to figure this out if you don't know your multiplication tables. So if we take the number 12, we'll make a little chart here. I'm going to take 12 and divide it by each number. So 12 divided by 1 is 12. So 1 is a factor of 12. 1 goes evenly into 12 times. Let's try 2. 12 divided by 2 is 6. So 2 goes evenly into 12 6 times. 3. 12 divided by 3 is 4. Because 3 goes evenly into 12 4 times. 4 is also a factor of 12 because 12 divided by 4 is 3. What about 5? Does 5 go evenly into 12? No. So 5 is not a factor of 12. What about 6? 6 goes evenly into 12 twice. So 12 divided by 6 is 2. 7? Nope, doesn't go evenly into 12. 8? Nope. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12, well, that one works. 12 divided by 12 is 1. So these are our factors. Let's change the color here so I can identify them. So 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, and 12. So factors of 12 are 1, 2, 3, 4, 6, and 12. So chances are if you know your times tables, you knew that these were the numbers before I even wrote this out, okay? And that's why knowing your multiplication tables off by heart is helpful. So otherwise, you're going to want to do a chart like this. There is also an online common factor calculator, which is at mathisfun.com. I will link that in this video at the end in the information for the video, and I'll also put it on Edsby, so you'll have a link to that. So if you're really stuck and you want to use the common factor calculator, you can type your numbers in there. But this is how we find them, okay? So I need you to know that factors are numbers that will go evenly into that number. So all of these numbers, 1, 2, 3, 4, 6, and 12, go evenly into 12. All right, that's going to be really important as we move on today. Now, greatest common factor. So let's go to another page here. Let's clear this. So when we talk about greatest common factor, GCF means greatest common factor. So really what we're doing are looking at two numbers that are the same, that go into larger numbers. So let's use an example. So we're finding the largest common number. So find the greatest common factor for, let's use three different numbers. Let's use 15, 30, and 105. All right, so we want to find the biggest number. So that means find the biggest number that goes evenly into 15, 30, and 105. So I'll save us a little bit of time, and then I've already done the chart like we did with 12. So I'm just going to give you what the factors are. So factors of 15 are 1, 3, 5, and 15. So 1 is always going to be a factor because 1 always goes evenly into the number. All right, factors of the next one, which are 30. So factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And factors of 105 are 1, 3, 5, 7, 15, 21, 35, up to 105. All right, so we have a list of factors now. So what we need to do is find the common factors. So factors that are the same between all three of these numbers. So all of them have 1. All of them have 3. All of them have 5. Oops, I circled the 3 instead of the 5 there. And all of them have 15. Now, what is the largest number out of all these common factors? Well, it's 15, right? GCF is 15. So 15 is our greatest common factor. This is going to become important as we move into looking at questions with factoring, because we need to pull out the biggest thing we can from the questions. So let's do some examples, and then we'll move on to special cases with trinomials and difference of squares. So factoring. So if we have a question, let's say we have a question like this. So we've been asked to factor 3x plus 6y. We have to find the largest thing that we can take out from these two terms. So what is the greatest common factor for 3 and 6? What's the biggest number that goes into both 3 and 6? Well, it's 3. So the GCF is 3. So a really simple way to do factoring, once I know what my greatest common factor is, I'm just going to divide everything by the greatest common factor. So divide by 3, divide by 3. Since I'm dividing by 3, I'm going to put my 3 right here outside my bracket. because I'm showing that I've taken 3 out of everything. All right, so now I can do my division. So 3x divided by 3, I'm just left with x. And 6y divided by 3, I'm just left with y, right? Or actually, I'm left with a 2y, because 6 divided by 3 is 2. So plus 2, and I have my y. That's it. That's our answer. Okay, so we have factored this into this. We've pulled out the greatest common factor, which was 3, and the bracket shows what's left over. So this is my greatest common factor. This is the leftovers. Okay, let's do another example. Change colors. We'll go over here. So let's say we have 17 AC minus 34 AD. So I have to find the greatest common factor for 17 and 34. So again, I can do what I did with 15, 30, and 105. Write out and divide and see what my greatest common factor is. I'm going to save us some time, and the greatest common factor between 17 and 34 is 17. So 17, I'm going to write this over here, GCF. So I can pull out a 17, but I can also pull out something else, right? Both of these terms have an A, right? So I'm going to pull out a 17A as my greatest common factor. So I'm going to put 17A outside my bracket, and I'm going to divide both of these by 17A. All right, so 17 divided by 17 is 1, and A divided by A, that's going to disappear. So I'm just left here with C. Now the next term, negative 34 divided by 17 is going to be negative 2. The two A's are going to cancel out, so I'm just left with D. And that's it, right? Again, 17A was my greatest common factor. C minus 2D is the leftovers. So really that's all that factoring means, is to take out whatever is the greatest common factor between those terms, and in the brackets we put the leftovers. Okay, let's do another example before I show you something a little bit different. So let's say we have negative 24 xy plus 16 x squared y squared. So I need to find the greatest common factor between 24 and 16. What is the biggest number that goes into 24 and 16? Again, I've already done this, but you could do those charts again and circle the biggest number, circle all the common numbers and find the biggest one. So the greatest common factor between 24 and 16 is 8. Since I have a negative here, I'm going to make this a negative 8. Okay, so I'm taking out a negative 8. And let's look at the variables. What's common between our variables? Well, we have an xy here, and we have an x squared, y squared. So both terms have an x and a y. So I'm going to say that my greatest common factor is negative 8xy. So I'm taking out a negative 8xy. So I'm going to do here is divide both terms by negative 8xy. Let's see what's left over. So negative 24 divided by negative 8. So 24 divided by 8 is 3, and those two negatives will cancel out, so I'm going to have 3. And then my xy's cancel out, so I'm just left with 3 there. Next term, 16 divided by negative 8, that's going to be a negative 2. Now I look at my variables. Remember that because I'm dividing, that means I subtract my variables, or subtract my exponents. So if I have x squared minus x, I'm just left with x. And y squared minus y, I'm left with y. This is my answer. Again, this was my greatest common factor. Oops. And these are my leftovers. So I need you to think about it that way. You've looked at these two terms here and said, what is the biggest thing I can take out of both terms? And that's your greatest common factor. And everything in the brackets is what's left over after you divide it. Okay? So that was a kind of a larger one with negatives, so I'm glad that we did that example together. Let's do an example with 3 terms. So let's see. So if our question has 4x squared minus 6x plus 8. Again, we need to find the greatest common factor between 4, 6, and 8. So the biggest number that goes into 4, 6, and 8. Well, 4 goes into 8, but 4 doesn't go evenly into 6, so it's got to be smaller than 4. So 3 wouldn't work, but 2 would, right? 2 goes evenly into 4, 2 goes evenly into 6, and 2 goes evenly into 8. So our greatest common factor here is going to be 2. Okay, so the biggest thing I can pull out is a 2. I'm going to put equals 2. Because if I look at, I know that in the previous question we took out a negative 8xy. Why can't I take any variables out here? This has an x squared, this has an x, but the 8 doesn't have an x on it. So x is not common to all of the terms. So the biggest thing I can take out is just that number 2. So I'm going to divide everything here by 2. And in brackets, I'm going to put the leftovers, right? So 4x squared divided by 2. 4 divided by 2 is 2. And I have this x squared left. Negative 6x divided by 2. So negative 6 divided by 2 is going to be negative 3. And I keep my x. Positive 8 divided by 2. 8 divided by 2 is 4. So that's plus 4. Once again, this was my greatest common factor, and all the stuff in the brackets are the leftovers. All right, so that was a trinomial that you've just factored there. Now, some trinomials, let's clear this actually. We'll change our color a little bit. So if we are factoring a trinomial, oops, here the first or the leading coefficient, CIENT, where the first coefficient is 1. So here's a little shortcut for you. So let's use this example. Let's use x squared plus 5x plus 6. All right, when we have a question like this, so if that first coefficient is 1, this is, right, because we have x squared. That means the number which is the coefficient of this first term, is equal to 1, right? Because we don't have a number there, that means there's an imaginary 1. So there is an imaginary 1 here. All right, so because there's an imaginary 1 in front of the x, this little trick will work. So in order to factor this trinomial, we need to find two numbers, that are going to multiply to give us the third term, which is 6, and add to give us the middle term, which is 5. So what we have to think here is, what are two numbers that would multiply to give us 6 and add to give us 5? Well, let's think about what numbers multiply to give us 6. So if we think about 6 here, 1 times 6 is 6. 2 times 3 is 6. 3 times 2 is 6. Now 1 and 6 don't work, right? Because yes, 1 times 6, if I multiply that, what did I just do over here? Let's fix this. Oops. Sorry about that. What I have to think about here is that 1 times 6, even though, oh my goodness, I moved it again. Technical difficulties, ladies and gentlemen. All right. If I multiply 1 times 6, yes, I get 6. But I need these terms to also add to give me the middle term. So 1 plus 6 is 7. So this one doesn't work. But 2 times 3 is 6, and 2 plus 3 is 6. So 2 and 3 work, because 2 times 3 equals 6, and 2 plus 3 equals 5. So our answer here to factor this trinomial is x plus 2, x plus 3. Now the reason for this is because if I were to multiply this out, this is what I would get. Let's try that on the next page. So let's clear this. So our question was x squared plus 5x plus 6. And we said that 2 and 3 were the numbers that work. They multiply to 6, and they add to the middle number. So our factored form was x plus 2, x plus 3. I'm going to show you why this is, because if I expand this, I get x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. When I combine my like terms, I have my x squared. 3x plus 2x is 5x. And then I have my plus 6. So this only works in situations where, like I said, the first term, so this term up here, this x squared, doesn't have a number in front of it. If it was 2x squared, this wouldn't work. We would have to factor first by taking out our greatest common factor, and then we could reduce and factor it this way. But this is kind of a shortcut here. This works if our first term has 1 as the coefficient. Okay, so that is factoring a trinomial where the leading coefficient is 1. Now I want to look at difference of squares. So similar to what we've done here. So difference of squares. So with a difference of squares, we are looking at, it's kind of like we are reversing the greatest common factor. I just looked at my notes here. No, we're reversing multiplying polynomials. So if I have a question that is, so actually I'm going to write this down here for you, is the reverse of multiplying polynomials. So a difference of squares, it's like we have the answer and we have to find the question. It's like Jeopardy for math. We have the answer. We have to find the question. So let's use the example of x squared minus 25. So what we have to think about here is that x squared is really just x times itself, right? This means x times x. What we have to find for here, for this 25, is that what number squared is equal to 25? Well, what squared equals 25? What times what equals 25? Well, 5 times 5, right? 5 squared is 25. So what we're doing here is we are kind of expanding this question out into 2 binomials. So I can write brackets. So x times x, I've got x's in both brackets. Now, if these two numbers are going to multiply together to give us a negative 25, this is really important here that this is negative. So x squared minus 25. So what two numbers are going to multiply together to give me negative 25? Well, one of them is positive 5, right? So x plus 5. But if I put x plus 5 in the second bracket, that means I have positive 5 times positive 5. That's not going to give me this negative, right? This negative means I have to multiply a positive and a negative. So if I have x plus 5 in the first bracket, I have to put x minus 5 in the other bracket. Does that make sense to you? Because 5 times 5, yes, equals 25, but we have the complication of the question has a negative in it. So we have to have the opposite sign in the bracket. So a difference of squares has two brackets, two binomials, that are the same, except for the signs. So x plus 5, x minus 5. That is a difference of squares. And I'm going to show you why this works. Let's clear this. So we had, our answer was x plus 5, x minus 5. Well, if we expanded this to check it, we would do x times x and get x squared. X times negative 5 is negative 5x. Positive 5 times x is going to be plus 5x. And positive 5 times negative 5 is a negative 25. When I combine my like terms, this x squared is on its own, so x squared. Negative 5 plus 5, those two terms just disappear, right? Because negative 5 plus 5 is 0. So all I'm left with here is minus 25. So we are back to the question. This was our question. So we have found a way to go from the question, or the answer, to the question. All right, so our question is really like giving us the answer. And what we had to do was find two numbers that multiply by two of the same number that multiply to give us 25. And we have to use opposite signs. Because if we use the same sign, this wouldn't work. We wouldn't get a minus 25. Let's do some examples. Just to check. Let's do an example of difference of squares. And then we'll do some examples with the trinomials, just to make sure that we've got that. Okay. So let's do another difference of squares. Let's say that we have x squared minus 36. Okay, so we know that this x squared is x times x. What two numbers would give us 36? What is the square root of 36? Square root of 36 is 6, because 6 times 6 is 36. So that means, so how do we write this answer? We're going to have two binomials. Both of them have an x in them. Now, if 6 times 6 gives us our 36, remember we have to pay attention to this negative. That means one of these 6's is positive, and one of these 6's is negative. So our answer would be x plus 6, x minus 6. And that's our answer. We can check it over here. We can do x plus 6, x minus 6, x times x is x squared. X times negative 6 is negative 6x. 6 times x is plus 6x. 6 times negative 6 is negative 36. When we combine the like terms, we have x squared. These two terms in the middle are going to cancel out because negative 6 plus 6, they equal 0. So x squared minus 36. So we're back to our question. So we know that this answer is right. Okay? So that's a difference of squares. Let's look at a trinomial like we did just a bit earlier in this video. So if we have a question like, so we're going to do one of those 3-term questions. I should have done these before we looked at the different squares, but I forgot, so I want to do these with you. So x squared minus 7x plus 12. So this question, remember, we need to find two numbers that multiply to 12, but add to negative 7. So a negative 7. So what numbers would multiply to give us 12? Let's think. So, well, 1 and 12, and 2 and 6, and 3 and 4. All right, now 1 and 12 aren't going to work, right? Because 1 times 12 is 12, but 1 plus 12 is going to be 13. So that doesn't work. 2 and 6. 2 times 6 is 12, but 2 plus 6 is going to be 8. So that doesn't work. 3 times 4 is 12, and 3 plus 4 is 7. That's positive 7. So here now we have to think, what if these are negative? Right? Negative 3 times negative 12, negative 4 is positive 12. A negative times negative is a positive. Negative 3 plus negative 4 is negative 7. So this works. We had to be careful here in that we have to have negatives for this to work. So if we know that those are our numbers, we can write our answer here. So our first bracket, draw my 2 brackets. So the first one, both of them are going to have x's in them. So I've got a negative 3 and a negative 4. Okay, and we can check this to make sure it works. That was our answer. But we can check this by doing x minus 3 times x minus 4. So x times x is x squared. It's not a great equal sign. There we go. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. And negative 3 times negative 4 is positive 12. When we combine our like terms, we have that x squared. Negative 4 minus 3 is going to be negative 7x plus 12. we're right because we're back to our question. This was our original question, right? So again, like I said earlier, this works in situations where the first term, this leading coefficient, is 1, right? When we just have an x squared. All right, I think I have one more example of this that we can go. Yes, let's do this. Okay. So what if we have a question like this, where we have a trinomial, but that first term is not a 1. So if I have 3x squared plus 21x plus 30. Okay, this is a trinomial, so we've got 3 terms. We're going to pull out the greatest common factor. So take out the greatest common factor. So greatest common factor between 3, 21, and 30. Well, it can't be any bigger than 3, right? 3 is our smallest number, so it can't be any bigger than our smallest number. But 3 works for all of these. So we're going to take out the 3, and we're going to divide everything that's left by 3, right? So 3x squared divided by 3, I'm just left with an x squared. 21x divided by 3, well, 21 divided by 3 is 7, so plus 7, and we still have that x. It's a terrible 3 at the beginning here, I'm going to fix that. And 30 divided by 3 is 10. So there is my trinomial. I've taken a 3 out, but now I can do what we just did with terms where the first coefficient is 1, right? I have the x squared now because I've taken this 3 out. So I'm going to keep the 3, but I'm going to factor what is left. So factor what is left in the bracket. So what I'm going to do now is I have to think of, so find 2 numbers that are going to multiply to 10 and add to 7. So what are 2 numbers that multiply to 10 and add to 7? So let's see, what numbers multiply to give us 10? So 1 times 10 is 10. 2 times 5 is 10. We can't really, no other numbers will work, right? So if I multiply 1 times 10, I get 10. But if I add those numbers, 1 plus 10, I get 11. So that doesn't work. 2 times 5 is 10. And 2 plus 5 is 7. So these numbers work, right? The numbers are 2 and 7. Two and 5, sorry, that give us 7. So now I can write this. I'm going to keep that 3 that I took out at the beginning. And what are my brackets going to look like? Well, remember, I'm going to have an x in both brackets. And one of my numbers is 2 and one of my numbers is 5. So one bracket is plus 2. The other bracket is plus 5. And that's our answer. All right, so I hope that that is helpful for you when looking at factoring and greatest common factor and difference of squares.